Seprogen's state-of-the-art downstream bioprocess chromatography systems with inline buffer blending capability to reduce the facility footprint and reduce the number of FTEs while increasing productivity of your downstream process for bioprocess intensification. Continuous chromatography with inline buffer blending. The QuantaSep Fusion Elite and QuantaSep Adept Elite.
Welcome everyone. Today we are going to talk about two very important landmark products that Seprogen is introducing for bioprocessing. The first is the QuantaSep Fusion Elite system, and the second is the QuantaSep Adept Elite. Now that's a mouthful. What do these mean? QuantaSep, of course, is our brand name for all our automated chromatography systems, whether they're multi-use or they're single-use or they're continuous systems, of which we have many models. The Fusion is the name that we've ascribed to our continuous system, and Elite adds the component of buffer stock blending into these systems so that it's integrated into these systems. In the continuous systems, the harvest is first loaded onto the first column, so there are 3 columns, and the flow-through goes on to the second column, while presumably the third column, which is already saturated, then goes through the non-load phases of washing, elution, regeneration, and then equilibration. And then when the first column is completely saturated, then the flow moves on to the second column. That becomes the loader column. And then the third column, which is now ready past post-equilibration, then becomes the follower column coming out of the load is coming off the first column. And now the first column, which is all ready to go, can then become the harvest column, right? So the flow goes on to the first column. What's really unique about this particular system is that we've incorporated into continuous processing on-demand inline buffer generation from stock concentrates. Okay? So in this machine, instead of just having your standard wash, elution, regen buffers or concentrates of that with Wi-Fi that you can blend and dilute online, here you can actually have Wi-Fi and stock concentrates of the mono basic, say, phosphate and a dibasic phosphate, and let's say a 3 molar salt. So the 2 components, concentrates of the 2 components of the buffer and salt, and maybe some additives that you might be using along with Wi-Fi, so that in line, when you actually pull up equilibration and you enter the molarity of the equilibration buffers, you can actually enter that as well as the pH and conductivity set points, and the pumps will automatically blend themselves, ratio the flow rates to give the right pH and the right conductivity, and the sensors in the system post-mixing then provide the feedback to the pumps to ensure that the right composition of buffer is delivered to the columns. In continuous processing, as you might be aware, you don't have large batches that you're processing one step at a time, so that only one unit operation is being used while the rest of the unit operations down the workflow are not used. So the utilization of the plant is not continuous. So you can make much smaller plants with much smaller footprint facilities by running continuously. However, that comes with a downside. And the downside is that you're running the process continuously, but you're making buffers in batches. And these buffers have to be made in a different facility, down the corridor, in a buffer making space. Even you might have a buffer making system there. That's no use, because then you have to fill up totes, you have to QC the buffers, bring them on to the system, and then run them, and as soon as those are exhausted, move those totes out and bring new totes in. So you got people running up and down, bringing buffers, while you're running a continuous process. Well, we've done away with that. You can just have stock concentrates right on this skid. So you can see how compact the skid is. It's 4 feet by 4 feet by 6 feet. right? Really no bigger than a normal chromatography system. And you can have stock concentrates and Wi-Fi connected and make buffers as you do the chromatography. So no intermediate holding tanks, nothing. And there's one HMI. The operator basically is running his chromatography system, continuous chromatography system. He programs it, he or she, programs it, and then they just go ahead and run the chromatography system, and it runs unstopped. It's got various sensors in it, pumps, of course, and so you can run continuously one cycle, next cycle, and loading is always continuous while the elution is also continuous, right, with 3 columns that are running. So that's our Fusion Elite system. The next one, because chromatography, you have multiple chromatography steps in a biological process, and so in this particular case, for instance, you might be coming off a 2,000-liter perfusion bioreactor with very high titers. So these machines are 10 liters a minute, single-use continuous systems, right? The entire flow path is removable, so you can run a campaign, change out the flow path, and put a new flow path in, right? So in many cases where, for instance, the first step might be a protein A capture step, you've got the 3-column continuous process that's going on, after which you move to viral inactivation, and then you go through an AEX step. And because that's a flow-through step, some people could have that as continuous, or because you have very long times for saturation, you can just run it as a normal chromatography step, which is what this particular skid, which is our Adept Elite. Adept is the name that we have given to our single-use chromatography system, and Elite, I already explained, integrated into this machine the buffer making capability from stock concentrates, right? So we will go through it and we will explain that to you. So now in this machine, we can go ahead and do that chromatography step with inline buffer blending. And then in some other cases, we may have multiple pumps. Here we have 4 pumps, which is the water pump and the acid component of the buffer, the base component of the buffer, so concentrated base component of the buffer and acid component of the buffer, and concentrated salt, so maybe 3 molar salt. In other versions of the machine, we may have just 2 columns, so 2 continuous steps. Or we may have another pump if we are adding another component to the buffer. Or we may have the ability to change different pHs. So for instance, the equilibration may be at 1 pH, the wash may be at a different pH, the elution may be at a different pH, or you may be running a linear gradient, or you set the beginning and end points of conductivity and you can run your gradient. In the automated program that you're going to see later, we can set the set points for the pH and conductivity, and those will be hit within a minute. So a very versatile system is really what the future is of chromatography. We're very excited about that. And we'll talk about the individual, the layout of the machine next. We'll talk about where the different components are and the PNID next, so that you're going to be able to see how this is laid out and how this is actually pretty easy to incorporate into your process very seamlessly in the existing footprint that you have, and right away be able to attain all the benefits that such technology offers. So as we just discussed, these systems are really designed with the objective of bringing productivity to the workplace as titers have gone up. So as titers have gone up in cell culture, fermentation, what have you, the equipment, downstream equipment, has become a bottleneck and has become bigger. Workflow has gotten complex, and very often new facilities have to be designed, walls torn down to accommodate these higher titers and higher capacity upstream. So this is really designed to mitigate those issues and bring about higher levels of productivity downstream to match all the upstream higher capability and capacities that are going on in small footprint and probably even existing facilities, right? So a machine like this, or machines like these that we have, enable you to get that level of performance and productivity with small workforce and be able to operate in a small GMP manufacturing facility with very high outputs. So now let's talk about the specific system that we are looking at. Okay? So if you look at the PNID here, you have shown here is the harvest pump. Okay? So the harvest is being loaded, going through the pre-column sensors, pressure sensor, conductivity sensor, pH sensor, through the bubble trap. There's an air sensor which can automatically eject any air out of the system in case you have to bypass the bubble trap, and then going on to one of the three columns, right, for loading. And then below that, you see the four pumps, the Wi-Fi pump, water for injection, and then you have the stock concentrate of the acid component of the buffer, and then the concentrate of the base component of the buffer, and then the salt. And then these four are blended together in the right ratio. They come together with an inline mixer. You've got pressure gauges and flow meters on each of these, at the end of each of these pumps. They're blended together, going through the sensors, pH and conductivity, and then feeding back to the pumps to give the right ratio for the set points of pH and conductivity. And then you go through inline filters. So in many cases, you may want to filter your harvest. So we have two filters and a bypass. So while one is saturated, then it automatically flips to the second filter while the first can be interchanged and then back. And then after that, the flow goes to the bubble trap. So if there are any extraneous bubbles, then those could get connected, those could get collected, so it doesn't go on to the column. And then for safety, we also have an auto air eject system. This is really one of Seprogen's key features, where we can automatically detect the size of the air bubble electronically and be able to automatically eject it out of the system, right? So it's pretty cool. You can actually operate the system without the bubble trap. And then you go through the column, right? The harvest goes through column 1 onto column 2, while the buffers are being directed to column 3, as we discussed. And then you've got the post-column sensors, pH, conductivity, and UV. And at the end of each of these columns are 3 fraction outlets. Now back to the input side. On the buffer side, you can see we have 4 pumps, the Wi-Fi pump, the acid component of the buffer, the base component, and then the salt. And then, as I said, these are blended together. And so they can have there, of course, you have the pH and conductivity sensors feeding back to the pumps. So they are ratioing with smart algorithms so you can achieve the right, the desired pH and conductivity. Okay? And then these buffers then can go to the non-load column, one of the 3 columns that is going through the equilibration, wash, and elution phases. So these systems also come equipped with a very exciting leak detection technology. If there is any leak, the system catches it, gives you an alarm, and pauses the run, and thereby preventing any loss of batches.